Welcome to Unit 5.1 on cell division in the cell cycle. I'm Wendy Nofke and I'm going to be your presenter for this short clip. All life starts out as a single cell. In order to have more cells in a larger organism, this will require cell division. In cell division, the parent cell divides to form two new daughter cells. This process is simpler in prokaryotes than it is in eukaryotes. In prokaryotic cells, these are going to use binary fission. First step is DNA replication, where two identical copies of the chromosome will be made. The chromosomes will segregate and move to opposite poles of the cell. After the chromosome has separated, you'll have cytokinesis, where the cytoplasm will divide, and you end up with two different cells. Both of these cells are genetically identical copies of the parent cell. Eukaryotic cell division is a little bit more complicated. This involves two major steps: mitosis, which is division of the nucleus, and cytokinesis, which is division of the cytoplasm. We can divide the cell's life cycle into two phases. M phase is going to include both mitosis and cytokinesis. This is the relatively short phase of the cell, but this is the division phase. Interphase is going to include three parts: G1, S, G2. These are phases where the cell grows, does its normal routine activities, and prepares to divide. As you can see from the diagram below, the M phase is just a very short part of the cell's life cycle. During interphase, we subdivide this into three shorter phases. The G1 phase is your growth phase 1. During this time, you're going to have rapid cell growth. The cell is doing its routine activities. It's doing its normal job. It will make copies of some of the organelles, but this is the majority of a cell's life. During the S phase, or synthesis phase, DNA is going to be replicated. Here it's starting to get ready for when it eventually goes into mitosis. During G2, or the growth phase 2, the cell takes the final steps in preparation to divide. As we go through this cycle, we want to have some control over this cycle to make sure the cell does not move on to the next phase of the cycle before it is ready. So in order for this to happen, we have some checkpoints. We have a G1 checkpoint that's going to make sure the cell is ready to divide. If cells are not able to pass the G1 checkpoint, oftentimes they will go into what we call a GO, or a resting phase, which will be a non-dividing phase. This is actually the majority of human muscle cells and nerve cells that are going to be in the GO phase. We have the S checkpoint. This is going to determine whether or not the DNA is replicated properly. We want to make sure that the daughter cells have copies of the DNA, so this checkpoint is really important to make sure that they are actually there. The mitotic spindle checkpoint that's going to occur during division makes sure that the chromosomes have aligned. If the chromosomes haven't aligned, the two cells aren't going to get equal copies of the chromosomes. Cancer is an example of when the cell cycle is no longer regulated and has gone wrong. This may be due to DNA damage, and most cancers are going to be an accumulation of multiple mutations that have occurred over the life of the cell. A couple of terms that we often hear associated with cancer that you may like to have clarified are below. A tumor is going to be a mass of abnormal cells. These are just cells that are not normal. They are not necessarily causing any problems. In most cases, these can just be surgically removed if they are causing problems. Metastasis is the term we use for cancer cells that are no longer anchored. When they're no longer anchored, they run the risk of spreading to another location and creating another tumor.